Good afternoon, all participants. So now let me move on to the second day, third session of the lecture by Dr. B V Kiran Kumar, Associate Professor, Department of Civil Engineering, Government Sri Krishna Rajendra Silver Jubilee Technological Institute, Bangalore. So my colleague Ganesh will introduce Sir profile.
A very good afternoon to one and all. I am Mr. Ganesh, Assistant Professor, Department of Civil Engineering, JIT Institute of Technology. It's my immense pleasure to introduce the current session speaker and also my teacher, Dr. B V Kiran Kumar Sir. Dr. B V Kiran Kumar Sir obtained his bachelor's degree in civil engineering from Dayanand Sagar College of Engineering, Bengaluru, Karnataka. He obtained his postgraduate degree in highway engineering from UVC, Bengaluru, Karnataka. He obtained his doctoral degree from Vishveshwaraya Technological University, Belgaum, Karnataka. Dr. B V Kiran Kumar Sir is currently working as an associate professor in the Department of Civil Engineering, Government Sri Krishna Rajendra Silver Jubilee Technological Institute, Bengaluru. He has 8 years of industrial experience, 17 years of academic experience with 14 years of research experience in the field of highway engineering. Professor Kiran Kumar Sir has published more than 25 papers in reputed international and national journals. He is a member of Standing Appellate Committee of AICTE New Delhi, is a life member of Indian Road Congress IRC and Indian Waterworks Association. Professor Kiran Kumar Sir has chaired a technical session at 6th International Conference on Sustainable Aggregates, Pavement Engineering and Asphalt Technology held at Liverpool John Moores University, United Kingdom. Sir is the consultancy coordinator at Government Sri Krishna Rajendra Silver Jubilee Technological Institute, Bengaluru, and has received project grants worth more than 30 lakhs. His interaction with professional bodies includes World Bank, Ministry of Road Transport and Highways, Indian Road Congress, Public Works Department PWD Karnataka, National Highways Authority of India NHAI Karnataka, and Karnataka Rural Road Development Agency KRRDA and National Rural Road Development Agency NRRDA. Apart from consultancy work, Sir also guided 2 doctoral degree candidates and 4 students are currently pursuing their doctoral degree research under his supervision. He has guided more than 35 projects under master level. These are some of the extracts of his achievements taken from his profile. Dr. B V Kiran Kumar Sir, we are very much glad to have you in this occasion. Thank you very much for accepting our invitation to grace this occasion. Now I request Dr. B V Kiran Kumar Sir to continue the session. Thank you, sir.
Thank you, Ganesh and Keshav, for that wonderful words that you have told about me. Good afternoon to one and all the participants who are joining this particular AICTE induction program. I've already been introduced. Without wasting much of our time, let us get into today's presentation. As you are all aware that the title given by me is somewhat different from the rest of the presentations that you might have gone through. Before starting the presentation, I would like to throw some light on the background, why I've chosen this and what exactly we are going to discuss in a time frame of 1 hour. Now, if you see that I have told equipment's name, whether it is going to be a boom or is it going to be a curse for the bituminous mixes? Why I chose this is you need to answer at the last after listening to me, whether it's going to be a boom or whether it is going to be a curse for the entire fraternity of mixed designs that have been handled. I was told that the audience are all from different parts of country where they're all into this particular assignment of either related to civil engineering or they're related to more of the academics and teaching learning process, innovation, and as well as research. So not sticking on more towards the academics or sticking on to the research only. I've blended and I've tried my level best to bring up this presentation. Now, without wasting much of your time, let me start my presentation. I hope the screen is visible when I share this. Kindly guide me if it is not there, please. Am I visible now with the screen? Is it available? The presentation is visible. Can
Yes,
anyone?
sir. Yes, sir. Visible, sir.
Thank you. Thank you.
Yeah, please make it full screen,
So
sir.
I'll put it onto the slide mode.
Yeah.
Okay.
Thank you so
Yeah.
much.
Thank you. Thank you. Yeah. Now I think it's in the slide mode. Okay. Let me begin the presentation saying that the roller compactor cum rut analyzer is a complete concept that I have developed indigenously on my own. It's a brainchild of myself and my two gurus who had given me the chance or opportunity to work on this particular project. Both Satyamurthy sir and Dr. HSJTI for my research program. When I initially went with this particular concept, even they were taken back that whether this is going to work or not. So through my presentation and through this particular complete topic of roller compactor cum rut analyzers quality tool for bituminous mix design, you'll be able to see the various changes that have come across or the sea changes that you can witness. So let me put the disclaimer first, because when we present many of the things comes in this particular slides and people feel that, okay, they have not taken my permission to put this particular thing. Though the entire work belongs to me, maybe during photograph or during some case when people are seen here and there, our participants, they may feel bad. So I put this disclaimer. With that, coming down to the content, if you see that the entire presentation, I put into this 5 basic heads called as introduction, material evaluation and selection, need for change, change suggested, as well as the conclusion. So I start with the basic introduction for the people. Anybody who is either from this background or not should be able to understand what we are speaking and what we have been practicing and what needs to be changed when we are doing certain kind of a research or a kind of a problem statement to be tackled. And then we come down to the suggestions that needs to be made or the changes that needs to be made. Finally, we'll draw the conclusion together after listening to the entire lecture. Now, if you look into the introduction, in the field of highway engineering, basically, you might have seen that the country is progressing a lot with the various national development plans that are coming, the rural road development plans that are coming. So there is a due thrust being given by the country to develop the infrastructure in terms of connectivity or communication, which is road networks. Recent government is also bringing up a lot of projects which are going to be fruitful in coming years when the next generations will be enjoying the benefits of it, when the complete project is put on to the working plan or working way. So right now, the inception, the plan, the various strategies that have been taken place is going to show its results or yield its results in another 5 to 6 years or max of 10 years if everything goes right. Now, in that direction, if you see, most of the time, our roads which are being constructed are all constructed on a very scientific manner with a lot of inputs that needs to be put into the construction it is taken. But when we look back the history in the year 1920s, the Hubberfield was the first mixed kind of a thing, or can we say that the top layer, which is the most crucial part of any payment. When we look into the payment, there are 2 types of payments, flexible payment and rigid payment. Right now, I am talking about the flexible payment. So to the people who understand flexible payment is basically a kind of a, I hope most of them are civil engineers, and I also got that there are some other people. That's why I'm giving a brief introduction here. So the payment which looks black on the top surface, which has got a black substance, basically built with bituminous material, it is called as the flexible pavement because it has got a nature of acting as a flexible material rather than acting as a rigid slab, which usually tends, or which is the tendency of the concrete pavements which we have seen, which basically looks gray to white in color. So the basic difference is this looks black, flexible pavement, and that looks gray. So when we look at the black substance, it requires some scientific process of designing it. And in that particular issue, the mixed design, what we call the mixed design is bringing this aggregate together with different sizes, putting them together or bonding them together or holding them together using some binder. And that black substance, that binder which we are using, is called as bitumen, which is again a petroleum product which is obtained, or the waste or a byproduct of a petroleum. When the humus is treated and all the light oils are taken, the leftover portion which is there at the bottom is known as bitumen, which is used for road construction. So the first time when they tried was in 1920s. Then in 1930s, Hume's stabilometer came into picture, or they gave a different type of a design which was much more modified than the Haberfield-Fields method. Now the real thing that was done, a kind of a mixed design which gained some popularity and sustainability, was in 1940s by Marshall. Bruce Marshall in 1935-40s, when he found that the requirement of the runways due to the World War being going on and the shelling bomb being thrown onto the runways and taxiways were causing a lot of damage to the pavement, he wanted a stiffer layer which can resist this, and a quick means of designing that, and which is stable. And basically it was based on the three criteria of stability, as well as the minimum optimum dosage of binder that should be given, which can resist both the change in temperature, change in wetness, and various other issues. Marshall came up with this standard of design. But everything is empirical, recipe standards, and very few developments have taken place. And for your surprise, even today, I think everyone will endorse, we are using Marshall method in almost all the highways that have been constructed in India. Even today, we are using this, and we have been following religiously following the Marshall method when it comes to the design of the top black layer. So what made me to think that why we need a change onto this? Now, from 1940s, if you see the kind of traffic that we are experiencing, the kind of fatigue reputations that are coming onto the pavement is tremendously changed the scenario, and the stresses are developing, mounting onto the pavement in more and more terms. If we say it is in terms of the cumulative standard axles, the vehicles that are moving onto the pavement, and we have the weather conditions which are changing due to the climatic change. So the wetness again becomes a major issue in many of the places. If you have witnessed, the failures of the pavement are basically taking place due to lack of proper drainage or the moisture that is coming. So we need to tackle 3 W's. One is weight, another one is weather, another one is wetness. So the 3 W's, if we are able to tackle in flexible pavement, definitely it is going to perform till its design period. So this was triggering and made me to search what exactly is happening. I cannot simply say that the practice which is from 1940s, which we have been designing, is going to be replaced by a new set, which I am going to say people will definitely laugh at me when I go and try to explain something new. So I had to make some background search, understand basically what is exactly happening and what we need to do further. So I just went through deeper and deeper and found out that the 3 major issues in the permanent deformation sector where the entire world is tackling, that is called rutting, which is basically a kind of a deposition or a shear failure that takes place on the top surface, and the material consolidation takes place on the wheel path. On the national highways and the state highways and many major arterial roads, you might have witnessed this particular kind of a bowl-like structure, depressions formed on the wheel track. So the next thing was the fatigue cracking, basically due to the application of load and release of the load. and simultaneously causes a kind of a fatigue or causes the bending action onto the pavement, which in turn causes a kind of a tensile strength or tensile force being applied at the suffit of this layer, that is the bottom portion of this layer, the black layer, and which tries to pull on the either side, radial tensile strength. This causes a rupture if the bonding or the forces or the stress that is applied is more than what the material can withstand within its elastic range. It starts tearing apart, and the aggregates which are held together, for your information, is all with a layer of at 6 to 8 micron. So the bitumen which coats onto the aggregate surface, its thickness would be around 6 to 8 micron each aggregate. So when they are held together with this 6 to 8 micron thin layer, they are subjected to this kind of a tensile force, and if they are not able to withstand, it starts cracking. So people think that crack comes onto the top. It's not the way. So the most of the reason would be from the bottom. We need to check when the crack appears at the bottom, when the tensile strength are more, then it starts propagating onto the top because there is a discontinuity of load being transferred from the subsequent frequent loading of the vehicles or the wheel. When it starts moving on that particular area, it transmits the load. The load, when it comes onto the bottom, starts acting in a different way at the crack portion because it is not a monolithic structure. So the difference transmits onto the surface. By the time it reaches onto the surface, the damage is already done. So this is what the fatigue cracking comes into picture, where India, both these are predominant, fatigue cracking and rutting, because we have a climate, our topographical location or the geographical, if you see, we are at the southern hemisphere, where most of our part falls into southern hemisphere, where we have a kind of a tropical climate region where the temperatures are on the higher side rather than on the lower side. So these two becomes very predominant when we look into the design factor. So up to from Kanyakumari till the Kashmir, we have this, and as well as from the desert or the Porbandar to Siachen, we have almost 90% of our geographical area consists of higher temperature rain. So the third most failure that is caused is due to the frost action, basically, where the lower temperature comes into picture. This is very limited to few places in our country. We have this particular problem when the soil gets the moisture, and that moisture completely freezes and forms a kind of a ice, or we say that it can be, when it frost action takes place, this formation of water, conversion of water into solid form of ice increases the volume, and this volume causes the separation or the layer soil to, or it pushes away the layer of soil, which basically causes a discontinuity of load dispersion that is coming on to from the top layers, and that leads to cracking when the summer cycle comes, and this ice, which is already been in form of a frost action or it is formed, starts melting, and it gets away through this particular temperature rise as water or moisture escapes into atmosphere. Now the separation which was caused due to the expansion of water in form of ice due to increase in volume, that gap of the soil which has been pushed because of the increase of volume can never patch up on its own. So there, discontinuity of load again comes into picture. It's similar to what you have seen in the fatigue cracking. Their disintegration of the aggregates caused the problem. Here, the separation due to the pushing of this or the swelling of water into ice or frost action causes the gap between the two material, and that cannot come back on its own because it's not in such an elastic position to come back on its own, and the crack starts propagating when the load frequently is applied in those areas. Now, after understanding this three major, I need to tackle them during my laboratory design there may be a question that comes into mind whether this was not tackled in Marshall method of mixed design when they are doing it. The Marshall method of mixed design, or the way what I am trying to say, or using this roller compactor to do the mixed design, there's not much of a difference except for certain change in the procedure, the way we are looking it, and the test procedure. If we start asking a question, why we need to do this test, whether this is required for our Indian scenario, or we are just blindly following someone said and it has come into the courts and we have been practicing it because people have stopped asking the questions, accepting the things without looking into it. No, once we understand when the procedure is to why the continuous failure is taking place, I started asking all these questions, and when I started moving through it, there's a thin line between what we call it as a good and bad mix. It's a very thin line, or the definition of calling a good mix or bad mix. No one can define so easily without having certain data which completely supports us that this mix is performed well over a period of time. And it takes a lot of time to understand that. The design periods have to be, we have to wait till that, and the records have to be created, and progress or continuous monitoring has to be made, and then we can say it's good or bad. Now, this everything good or bad origins from a certain laboratory studies only. When the laboratory studies itself has got a lacuna, we are not looking at those lacuna and trying to simply say that the payment is not performing is not correct. So in that direction, when I started looking into why mix which performs well, or we call them as good mixes, and why we are saying in some, we are saying it is bad mixes. So I started looking into those aspects and collected a lot of data, did an extensive survey, literature survey, went to CRRI, spent about 6 months time there, and understood, went to the libraries and various literatures that were available throughout the country as well as abroad. I brought several things together, and when we did the first formulation, I said there's something which we need to define, a kind of a barrier through which if the mix passes, then we can clearly, critically or clearly say that the mix is going to be a good mix or a bad mix. In this process, when I was collecting even the strategic highway research program developed by the US government at that time under National Highway Cooperative Research Program, NCHRP, the super pair branding or super pair mix design was already in full swing when we did this particular exercise. So there was a lot of an influence on our way of thinking that we need to bring in super pair mix design. But I was quite hesitant that we cannot directly take up this super pair mix designs. I have met Professor Kandal also in many of the conference when we were talking, and in once he had come to Bangalore also, when in the same stage, we had shared the same stage and I had given the presentation. He was also quite convinced the way what I was trying to say, and he is known to be the best person for super pair who has worked for MCAT for such a long time, who has got a better experience in terms of mixed designs and in terms of various issues related to bituminous mixes. So I discussed a few people with like Professor Kandal and my professors and various agencies who are handling this. And I came out that usually any mixed design, irrespective of super pair, irrespective of Marshall method, these are only the compaction procedure which is going to change. But the more or the less, the steps which are required for a mixed design to be tailored remains the same. First being the material selection, second being the design aggregate structure, third being the design binder content, and fourth being the moisture sensitivity. Now, the people who are in this particular field can understand these 4 steps. For the general way, people apart from our field who are attending this session, I am telling you, I'll give you the complete picture what we are trying to talk till now. All that you have seen earlier was just an introduction and how the development took place. Now we are at the stage where we have come and zero down our problem that even though we do all these steps, 4 steps, and carefully choose our aggregate structure, carefully choose our binder which is required to hold these aggregate structures together, still we are seeing that the pavement failures are taking place within a premature period of 6 months after construction. Several times it is within 1.5 months and 3 months. I see that a lot of cracks coming onto the pavement. Why this is happening? This is a major question that I have always been asking. When there are so many quality control checks, so many people involved in it, and every point the records are being cross-checked, an independent agency, the PMC looking into it, third-party testing, so many things have taken place, but still the failure takes place. So any mixed design or any construction has basically got these 4 steps. One is to choose the material, right, which is required based on the project condition, what type of climate it is, what type of road it is, whether what kind of load it is coming, and what is the drainage condition, various other issues related to the performance of the pavement. We will be choosing the material. Second thing, once these materials are chosen, they have to be carefully structured to give maximum density. Means when they are all put together and blended together, we need to have a proper blending or maximum density which should come out. The third one is to give the optimum dose of binder to hold these aggregates which are carefully chosen from 1 and 2. To hold them together, we have to have a binder, and that binder, how much we should put for the given quantity of aggregate, has to be designed or has to be decided based on the level of compaction. This is where I found that we are failing miserably. Excuse me. We are failing miserably because most of our methods which are being used, for example, if I talk about Marshall method, the Marshall method gives the blow on to the aggregate structure which is carefully chosen in second step with certain binder content or a trial binder content to start with. After giving 150 blows, both onto 75 on the either sides on a cylindrical specimen of about 100 mm diameter, 63.5 millimeter height, we will be trying to check its volumetric properties and checking its stability after soaking it for 60 degrees centigrade to, and as well as the resistance to the deformation and as well as the flow, basically how the circumferential loading when it is applied, how the material starts crumbling or crushing when the load is applied constantly. So we, based on these parameters, we are fixing the binder content. Now, where is exactly, is this the same thing followed in the field? In field, it's entirely different. There is no dynamic loading in the field. Field has got kneading action. The roller runs onto the aggregate structure with binder, and then it starts compacting, and the densification slowly takes place after the number of passes is given, and the densification is cross-checked by either by sand replacement method or nuclear density method or by drawing the core and taking it into the laboratory. Now, in the laboratory, we are designing something with a dynamic or a hammer of 4.5 kg, 5.6 kg, dropping it from a 45 centimeter height, giving 75 blows, and we are not checking whether the aggregate which is receiving this blow has it been disintegrated or whether there is a fracture in that particular aggregate, whether the fragments have shifted from the specific sieve size because of this blow and the bigger aggregates disintegrating into smaller aggregate and contributing into the lower sieve sizes. So all these things are not checked in case of our mix design by Marshall, but still we try to go ahead with the mix design based on this particular 75 blows. I felt this is really wrong. But when we look into super pave, we have super pave gyratory compactor. Exclusively removing this Marshall compaction, they have got gyratory compactor where the kneading action comes, definitely appreciable. But the densification, or what we call it as the densification data of the mix to produce a 63.5 mm height and 100 mm diameter with the base plate being swilled or it is tilted at 1.25 degrees so that the aggregate gets the scope to move when the pressure is applied from the top. When the 600 kPa pressure is applied from the top continuously, from the bottom the rotation takes place or the swill takes place, and this slowly the material is confined. Now this gyrations that are to be put, initial, final, and the maximum gyration that needs to be done depends on the type of aggregates and the binder. Still, here it is too complex. The equipment itself is having too much of sophistication. The failures of the equipments are much higher because it works on air bearing basically, or the air being compressed through the compressor. Moisture damages causes a lot of damage to this particular specimen itself. So when we look all the pros and cons of the super pave gyratory compactor, and it's very expensive, very difficult to be maintained by the laboratory and the contractors. So Marshall always wins over that. Then again, the only use of doing the compaction, do we need to have so much of sophistication and the laboratory and so many steps involved and lot of fabrication? Equipment requires a lot of inputs, and various other supplements have to be added. Moisture air trap, then dryers we need to add to remove the humidity in the air and all those things. Now the fourth one is a common step, again like what we see in 1 and 2, 4 is mostly common both in case of your Marshall method you do, or your super pave you do, or any other method in the world if you do. The fourth one is moisture sensitivity, that is determined by taking the ratio of conditioned to the unconditioned sample by fixing the target rate, like about 85% of retained tensile strength should be taken into account to determine whether the moisture causes a damage to the mix. That is, the both thawing cycle and freezing cycle have to be looked into. So these 4 steps basically converts the entire mix design, and my step is always concentrated on the third one, because the binder content is the ultimate thing that it comes, and without knowing the targeting the maximum density, maximum air void, all the procedures that we are doing is going to be a waste, because it is not similar to the field condition. Except for the super pave gyratory compactor, it is somewhat matching to the field condition, but it is again a very costly equipment and very sophisticated equipment. Maintenance of it is always a problem, and it is most of the time under repair rather than functioning. Now, material evaluation in first step, what we are doing in most of the countries also is we were based on their grading system. Earlier we had penetration grading, but now we have viscosity grading. But penetration grading is a quick way where people are trying to understand by adding or by applying a load of 100 grams on a bituminous substance or a black substance, and understand the shearing rate of this needle for 5 seconds when this 100 grams is applied at 25 degrees centigrade, how much depth the needle will penetrate. So there's nothing which is coming out concretely saying that this is required as a performance test to the field. It is only the quick test to understand the grade of bitumen. Now the second thing is softening point test. Now this test is somewhat similar to your liquid limit, where the soil changes its state of solid to liquid with a small shear force with the maximum moisture content. Same way here, the bitumen, when it changes its phase from semi-solid state to liquid state or starts flowing at that particular temperature, when you heat this particular bitumen at the rate of 5 degree centigrade rise per minute, when you raise it, it is going to start moving, or the change of the solid to liquid state is where that we are interested. And this is very much useful to understand when the binder is used in the project site, at what temperature the binder loses its solid or semi-solid state and starts acting as a liquid and flows away from this aggregate instead of holding it together. So the next thing is the ductility test or the flash and fire point. The flash and fire point test is basically totally a safety test. It has nothing to do with the physical parameters of this particular binder. A flash and fire point, it only tells when you're handling bitumen, which is a petroleum product, it catches fire if you keep on continuously heating up to a certain point. And beyond that, if you start heating, it gives you a signal. It says, I'm going to catch fire. That is called as flash point. There will be some kind of a glittery, glowing thing. A blue sparkle will come on the surface of the bitumen when a fire source is introduced. And we need to note on the temperature. Nowhere it should be less than 220, which is used for paving grade. And when we look into, or if we ignore that and heat it further, again, if there is any source of fire onto the bitumen, it catches fire and burns completely. Now, ductility test talks about the workability or the layer of coating, which I was telling about 6 to 8 micron film will be coating onto the surface of the aggregate, holding them together, the binder together. If we are bringing two aggregates and coat this bitumen of 6 to 8 micron film on each, and if we bring them together, then they are together or held together, this aggregate is because of this 6 to 8 microns. So that stretching is what we will be checking in case of your ductility. Now, all these tests, even today, for your information, if you go to the Bureau of Indian Standard, they're all valid, and this is what every engineer is doing to select the material. That is, any person who is related to pavement engineering, flexible pavement, they are doing this only in most of the laboratories and the higher contract or the number one contractors who are doing this highway, national highways, expressways, or with bitumen are handling with these tests. Now, the third, now we are into viscosity grade bitumen, which is after several years they have done this particular change. The reactors have changed, but wherein the most of the developed countries are all into performance grade bitumen, PG grade bitumen, which I will explain in due course of time. Now, we need to understand the viscosity in terms of absolute and viscosity. So when we need to understand this, why we need to understand? Because we are handling a material which is a non-Newtonian fluid, which is basically changing its shear rate with change in temperature. So the viscoelastic material is what the binder is. It exhibits the viscosity characteristics. It also exhibits the elasticity characteristics. So we need to strike and understand for a given material how it behaves as a viscosity material, less viscous material, and how it behaves as a high elasticity material. We need to check and understand for better design of the pavement layer. So viscosity gives us the idea of the binder, when it is to be handled, when it is to be pumped, when it is to be transported, when it is to be coated, and the resistance when this coating is done on aggregate, when the temperature drops, how it can bind together and hold this particular matrix in together, and when it is compacted, gets densified. All these things depends on the viscosity. Now, I was talking about something called the PG grade, which is basically a performance grade bitumen, which is there, produced by most of the developed countries. Now, when we look into these specifications, why I'm bringing this is, all this time we were learning what we are doing in India. Even today, on this moment, when we are talking, we are following the same specification with certain modifications. In 2013, if you look, IS 73, when your choice of the bitumen is to be made with all the tests which I have told previously, 90 to 95% of those tests will be followed. And with certain changes like aging characteristics has been added with RTFOT, where are the other countries, this is a routine practice. They do for 3 criteria. One is for aging, another one is to measure the viscoelastic characteristics of the bitumen so that they can tackle the mechanistic design of the pavement, or the design values from this particular test goes into the pavement design. Then we have, this is what we have for rolling thin film wound test, which is for a short-term aging. That comes when you are heating the bitumen and pumping the bitumen from the reactor to the bitumen tank or to the bowser where it is to be transmitted. Again, the bowser reaches to the contractor place. Again, it is heated to keep the liquid in or bitumen in liquid state so that it can be easily pumped from the bowser or the truck to the tank of the contractor site. And pressure aging vessel is a test which is an accelerated test which tells about the bitumen's aging characteristics after 20 years. Means after construction, when you have used the bitumen after 20 years, how this bitumen will be hard, or it would have aged because of the free presence of oxygen and UV rays of the sun. So all these tests are a routine test in developed countries when the selection of material is done. We are not doing this, but still, without doing all this exercise, we expect that particular bituminous mix design and the engineer to sustain for the overloading that we are causing. Now, this is called a dynamic shear rheometer, which is basically done in order to understand the viscoelastic characteristics of the bitumen. This itself is about, we can do about 8 to 10 days course, how to do this dynamic shear meter. Just learning how to do this and how to do a strain control test, stress control test, how the loading is to be applied, and how to interpret that design or that particular result and transfer that into the field condition in terms of complex numbers, which is going to come out when the shearing force is applied onto this particular bitumen sample. Then we have rotational viscometer instead of your standard viscometer, which you have seen in previously, where we will be trying to find out measure the characteristics of the binder during flow. Then we have two simple tests, bending beam rheometer test and as well as direct tension tester, which are used to determine the behavior of elasticity of the bitumen at lower temperature. That is why in foreign countries, when a PG grade is mentioned, if they mention 62 minus 12, means the binder will act as or hold its viscosity at 62 degrees centigrade higher temperature, and will also hold its elasticity at minus 12 degrees centigrade. So that is called as performance grade. Both on the higher side as well as lower side, the bitumen will work. Now these are the equipments where you can see the rotational viscometer and the bending beam rheometer. It is a small asphalt beam on which 2-point loading is applied. The slope is taken, and we will be trying to find out how the failure takes place. This is a direct tension tester used for testing the binder when the values of its values are not being accurately determined by BBR, bending beam rheometer. These are required to understand how the pavement behaves, earlier part. So these complex values which I was talking about, the G star sine delta for unaged binder and aged binder are given here. The minimum value should be greater than this. Then after aging means during the service period and as well as in the later stages once the service period is over. So again, we have the values of G star sine delta, how after aging through RTFOT and PAV, whatever the value it is coming, whether it is falling within this range of 5000 kPa. So all these things have to be determined before finalizing. Similarly, for your test of low temperatural cracks, all these are related to my 3 failures: rutting, fatigue, and temperature or low temperature cracks. These 3 tests or these 3 have to be tackled in your test, and that is why they have done all these particular test examples, or the process have been developed. Now I was talking about the grading system is based on climate, which is basically, I have given an example, PG 64 minus 22. PG means performance grade binder, 7-day average maximum pavement temperature that would have been collected over a period of several years. That is what the higher side it is indicating. Minus 22 is the minimum temperature that area would experience, or the project to which the pavement run would have experienced. So 64 minus 22 means the binder will hold its viscosity without changing from solid to liquid, even at 64 degree. At the same time, if the temperature falls to minus 22, the binder will never become brittle. It will hold its elasticity even at minus 22. So this is a kind of a grading system is based on climate, and most of the countries are following, but we are not at this stage. Apart from this, under material selection, all other remains the same, because aggregate coarse angularity, aggregate and the fine angularity, or aggregate angularity is done, toughness, soundness, it remains the same. I will not take much time here. I will just get into it. Your shape factor or combined index remains the same. It is done in a very simple manner. They take this particular ratio as 1:5. Means instead of going for 0.6 times of its average dimension and 1.8 times of its average dimension, they have fixed it as 1:5. Means in the thickness is 1, the length maximum that aggregate can possess is only 5. If it is the thickness is about 10 mm, the length, the maximum we can allow is about 50 millimeter. And the second one is design aggregate structure. The SuperPave has given several control points through which it has to follow. Yeah, that same thing has been also taken into account, and even the Ministry of India gives you the upper and lower limits. Everything targeted to the maximum density that needs to be achieved for the mixed design. Now we are at the third step, the design binder content, where it is most important that the compaction is done with respect to the traffic. What do you mean by the traffic? Now, if the pavement has to breathe, it has to breathe in the sense when we look into the phases of the pavement layer or the top layer consists of aggregates. It consists of bitumen, which is liquid, solid, semi-dense liquid. And then you have your air voids. Now, these three have to be balanced if we have to see that the pavement works really good. So initially we do have a targeted air void content up to which the pavement is to be compacted in its service life. Means I will have a pavement with about 6% air voids. Now that targeted air voids is about 3%. From 6 to 3, the pavement air void or the decrease in that particular air void content by filling up of solid takes place due to the post compaction effect of the pavement. And the last point which we saw, or the figure which we saw, was AICTE 283. Believe it, my friends, up to this, whatever you have learned is only the theory portion of it, or I have condensed the entire research of 4 years into this small 4 years or 5 years of continuous research, only to understand into this 4 or 5 slides what you have seen till now. The 4 segments which I have brought. This is common in any method, whether it will go for Marshall method, whether you go for SuperPave method. My point of convincing to you all is the third one, where the compaction that we are doing using Marshall method is wrong. I don't say that gyratory compactor is going to be wrong, but gyratory compactor is too complicated to be handled by anyone in the field who is basically doing right now. The Marshall method is given by labor. Under for open air to cool down for 24 hours for further processing. But in case of your gyratory compactor, you need all kind of inputs that needs to be provided. Lot of efforts have to be taken. Binder to dust ratio has to be maintained, and there are so many things which basically causes a lot of difficulty when there is a failure of this particular equipment due to moisture and other harsh conditions in the laboratory as well as in the field. So till now you have learned. I'll just give a break here for you people to what you have understood. Even I need a break. I'll just take a sip of water. What all the dreams and aspirations of any person when he joins a company, he would look into. This is a kind of an ad. You can think. See, they would like to have a very beautiful parking spot, exclusive parking spot. Even anyone who is working in an academic institute, they need to have their own parking lot and parking spot where they can park their vehicle elegantly. If you have, and you have a very reliable company car, or persons who are working would like to love to have a car for their commuting and all working space, alternative working space. COVID has taught us to work on alternative, right one we are doing now online lecturing, everything, a good entertainment area. These things we are expecting from the mixed design engineer. All our roads should work elegantly, everything with all this sophisticated. We are spending lakhs of rupees, money of taxpayers is giving. Why the engineers are not capable enough? Questions are asked. So I am comparing. This is what you are expecting. This kind of a service is what you are expecting. Everything, an elegant meeting room inside a car, you need to have all this thing. A communal area to share your thought, what exactly has happened. Now, this is the condition where we are there with the Marshall method of mixed design, where we see this is what we are getting, and we want to use this, and we want to get a performance mixed design, which was of the previous slides. So I start saying that yes, we need to change, but that kind of affordability do we have, and India, does it require all those sophisticated testing? Yes, America, three things are very, very different: weather, wheel load, as well as the kind of wetness. The climatic change is erratic, so they do this particular exercise. But in India, when we have tropical climate, 90 to 93% of our geographical area is on the hotter climate and very less onto the lower side. Do we require a kind of a temperatural test required for the low temperature zones, where we require the BVR test to be followed, and then DRR test to be followed, direct tension test to be followed, which is not at all an essential component for us. So what I did is, first was to tackle this compaction issue. For that, I wanted to have the temperature range of our country, whether my thought process is correct or not. I wanted to cross check. So I contacted Indian Legal and then Meteorological Department. They gave me the statistics of 125 years data that they have collected. Even during British times, they have established these rain gauges, temperature gauges across the country, and they have been continuously monitoring the change in temperature, atmospheric temperature, humidity, whatnot. You will get the complete compendium in a CD. They will send it to you if you pay the price of 10,000 rupees plus GST and all. They'll give it to you now. Earlier, when we bought, it was about 4,000 change. So if you take this particular details, you can look into the complete country is divided into certain zones by the Meteorological Department. That is, they are divided India into peninsular zone, where the southern peninsular tip comes into picture. Andhra Pradesh, some portion of Andhra Pradesh, Tamil Nadu, Karnataka, Kerala will come here. West Central Zone, after that, the Deccan Plateau area, what you find, where you can see in my table, I have given the place, latitude, maximum annual average ambient temperature in degree centigrade, because you need 7 days maximum variation temperature, which is repeated in 100 years or 8,000 years, whatever it is. The minimum annual average ambient temperature, the minimum that that particular place would have experienced over its period of 100 or 125 years, and the minimum pavement temperature. How do we check this pavement temperature? This pavement temperature can be checked by making a small hole of about 20 mm depth, apply the glycerine onto it, and place the thermometer there and take the temperature of the pavement. Instead of that, we have used these two equations, that is about 20 millimeter depth, by substituting the latitude of that particular place and using this constant and temperature of the air, both maximum and minimum temperature of the air, we will be calculating the maximum pavement temperature. Minimum pavement temperature, if you see here, none of these regions are going below 0 degrees centigrade. You can see the peninsular region, West Central region, the minimum temperature, air temperature I'm talking about, is going below 0 degrees centigrade. So definitely the pavement temperature will never go below 0 degree at these places. So all this data was collected, and then we collected several types of binders that are being manufactured by various agencies and which have been continuously being supplied to national highways and state highways. I did all the research took up all the tests which you have seen earlier, penetration test, ductility test, and various too much of data. I'm sorry for that I have to compress this in one slide. Many of you may not have used a laptop or anything, or if you're using mobile, I really apologize for this compression of this particular data in a larger thing. Maybe the organizers can share this particular presentation so that you can get this slide and understand the values. So we did a short-term aging also onto this and did all these particular tests of the binders that are being used in India for the construction. Then for our surprise, you can see this video. Our situation was also like this. The monkey, by seeing those results, we had to get back, or we were astonished after doing this extensive research, collecting all this data. Our temperature or binders, which we have been using, even today, what they are using by your BIS 73 VG grades, are not able to cater to this temperature ranges that we have calculated based on the actual temperatures that have been measured by the Indian Meteorological Department. Bangalore alone requires a 60 centigrade binder to cater, or a PG grade of 59 to 60 to cater, wherein our softening point of VG40 does not even cross 50 centigrade. So what exactly is happening, where we are failing? Then again, if we use this binder and use Marshall method to compact, the Marshall method gives us an erroneous optimum binder content, because the carefully chosen aggregate disintegrates. Once it starts disintegrating, the surfaces which are disintegrated requires higher binder content, and that binder content cannot be accommodated within the air voids that we are designing it. So we are at a fault somewhere or the other at the beginning stage itself. In the laboratory stage itself, we are at fault. So that's why I showed you this video. Now, what is the results? Where exactly we are going wrong? Even our aggregates, absolutely, they are the best. You can see the results that are coming out with all the necessity tests, combined index, everything, soundness, aberration value, everything is perfect. Then why the pavement are failing? The selection of the aggregate structure is also well within the permissible limits given by the Ministry of Mode. We have camouflaged that with our super pave values also, to check whether the super pave values also follow, or the aggregate chosen under by super pave method, will it fall or match to our specification of Ministry of Road Transport and Highways. Now, once we did this, I was in a fix. So I thought, let me, with my friend and myself, we did a lot of research. We went to CRRI, did all the tests using the gyratory compactor, Marshall method, kept every specimen of the same binder content and aggregate. Then I came out with my own indigenous design called as roller compactor cum rut analyzer. This is where we are actually learning today what exactly we had to do. That was the complete background for this particular study. Now, this roller compactor, what I'm designing in the laboratory, or this particular equipment we are talking about, is similar to your roller which is there in the field. It rolls, and through kneading, it densifies the aggregate, or the densifies the material, bituminous mix. And this densification data is also captured. Means when the material changes, or it becomes harder and harder, or pushed together closer and closer, the maximum, without causing any damage to the aggregate structure, what needs to be fixed is taken, or targeted density is taken into account, and the volume required for the targeted density material volume is taken and compacted from loose thickness to final thickness, where the densification data is obtained. I'll just show you, this was the first generation when the thought process took place. with the limited funding, whatever was available with us, through which the industry institution interaction, convincing people. Any research requires funding, and we cannot spend from our pocket on such investments where lakhs of rupees comes into picture. So the industry sponsored us few quantum of money, and that we took it up, and we did the first initial design and called it as first generation roller compactor rut analyzer. It's a active model which is there. Now in this video, you can see that the wheel is moving on a arc plate, which is you can say a segment of roller, your roller segment, which is in arc shape. The segment on which the roller, if it is moving, it is a hydraulic pressure roller with the oil pressure being put with non-return valve to maintain constant pressure. So when the wheel starts moving, the relative position of the wheel, what it was earlier, will be taken into account, and then it is going to see how much it is digging. So automatically, when the densification takes place, a signal is passed to the equipment, and the roller switches off and comes back to its original position, and the specimen is ready. Now, there were so many drawbacks with this particular roller compactor rut analyzer initially, because of the reversing of the oil, reversing of the cylinder, the time shift or the phase shift. There were certain pressure losses, even in case if you put a non-return valve. The hydraulic machines, they have got some minimum effort, and the kind of pressure that we need to add for the roller plate, the hydraulic pressure that needs to come, or the piston needs to come, had to be redesigned to cause the kind of effect that we were looking into. So later on, once the drawbacks of the first generation was known to us, we took up the second generation roller compactor cum rut analyzer, went to the ministry, gave a presentation to the ministry. It was a second generation. This time we had a lot of knowledge, and we tried to construct this, made a complete kind of a animation series where this particular working of roller compactor cum rut analyzers could be explained. The machine was itself was 3D modeled and brought into the oil tank, the requirement of the oil tank, the pressure that can be generated, the depth of the equipment, everything was pre-planned and finalized. Even the mold and handling of the mold to compact these layers of bituminous material, to keep them in warm condition, the heaters and all these things were added. And in an easy way, the mold could be demolded by just lifting two rods. The mold could be split into three parts, and we were able to cause or compact this particular material. The movable plates up and down through a screw jack was giving me the flexibility of loose mix to be compacted to final mix, or when there is to be complete operation, or the thickness of the pavement layer has to be accommodated. It was completely touchscreen. Non-human interference was completely removed by adding auto screen and various other PLC operations which we had put. So we did the complete exercise onto this, got the funding, and then we tried to build this particular equipment. They did not stop there. We, after compaction, we thought, why don't we also have a second mode of working in this equipment which can determine the performance of the given bitumen. So to do that, we added a rutting model where the specimen, once it is completely designed, after constructing using this optimum binder content of the binder, a set of wheel was made to run to and fro with the selected tire pressure. Like say, if you want to apply 6.1 kg vehicles, kg per centimeter square tire pressure, how many passes it takes to cause the damage of rutting of 10 mm, 12 mm, we wanted to monitor. So there we added a set of wheels to this equipment, and that wheels were running to and fro, causing this particular indentation or causing the rutting test. The number of passes required to cause the set depth was recorded and captured in a PLC using a PLC memory slot. Now this is how the second generation looks into. That was the complete animation. You can see the working model of it. We are carrying out a rutting test where specimen was being cast and it is maintained, temperature is maintained at 60 degree or 55 degree or 40 degree or higher temperatures if you want 70 degree. How this payment performs, because if you see Rajasthan and other area, we have a payment temperature roaring about 75 to 80 degree. Now Bangalore itself is 60 degree. So there, if you want to maintain that temperature, you need the support of heaters. So this is how the rutting test works. Now, even then, our quest or the complete scenario of designing the payment layers in accordance with the field condition was not there, and luckily even IRC 37 came into revision in 2012. Then they in 2018 they have framed this particular guidelines on the same lines. We wanted to have all the 8 plates which is there in IRC 37 2018 to be tested at the laboratory, so that we will be confident to transfer our mixed design to the field. Whereas in case of Marshall, this possibility was not at all there. The optimum binder content of the specimen that you have prepared using Marshall method, how do you use that same quantity to construct or use to cast a slab? It was great difficulty for us. So that is the reason we tried to completely change this particular scenario. And we did a 3rd generation RCRA compaction. What is this RCRA 3rd generation compaction? It is a self-explanatory compactor. I think I'll give you the explanation because it may be in the local language Kannada and many of the participants are across the country. I will try to explain it in English. Now this specimen or this particular roller compactor cum ret analyzer is a complete depth of payment. Whatever the composition is there in IRC 38 37 2018, the same combinations can be constructed layer by layer in the laboratory. It is a model box study. There are stretch gauges, strain gauges embedded in these layers. Now these layers, when the strain gauges have been embedded, the strain gauges values are also taken when the wheel load is applied. Now you can see the top layer is being constructed now. We are doing the mixed design and we are constructing the top layer. The mixed design is already been done earlier using this roller compactor ret analyzer. Now we know what is the total quantity of top layer that is coming. We have mixed and applied the top layer on the prepared layers of the pavement. After DBM layer, the BC grade 2 layer is coming onto the top. Now once this is done, the complete box, once it is leveled off, a layer we are going to place a kind of a roller which is going to be sitting on an arc. Now this arc is a small portion of your total drum which you are seeing in case of a roller. Now this arc will cause the kneading effect when the load is applied on and on its segment. So the kneading apply with the pressure causes the material to settle down or compact together, bring together, densification takes place, and it also gets the scope for further movement without disintegrating. We are going to, without disintegrating, we are going to densify the layers. So you can see we are preparing the arch there. An oil is applied non-sticky so that the bitumen doesn't stick to the surface, and the arch is placed. Now once this arch is placed, the entire pavement cross section which is constructed in this box is just slided into that particular roller compactor, and then it is locked. So once it is locked, it cannot come out, and the sensor will get activated only once that bar is placed. Now, once that is placed, we will enter the requisite data that what should be the total depth of compaction that the layer should undergo, and what is the overall thickness of the layer that should rest on the DBM layer, which has been already constructed. If it is 40 millimeter, the loose thickness will be about 80 millimeter, for example. So we are keeping 40 millimeter to be compacted once the material starts densifying and the data gets captured in PLC. Now, once this is all done, the specimen is completely compacted, and the specimen which is as per the plate which is given in IRC 37/2018 can be done in the laboratory before transferring this to the field. The pavement layers which is going to come onto the field is already there. Now, once this is done, the rutting test can be done using this particular RCRA. Since the time is running, I will be just skipping this video to show you how the rutting test is conducted. Now, if you see the third generation, from first, second, you have seen the improvements that has been done. Now, the complete depth of the pavement can be done in case of your third generation. Now, you see how the rutting test takes place. Now, this is what the rutting test is progressed on the surface of the pavement. You can see the tires which is running onto the pavement and causing that particular mark. Now, the load that is applied onto the tire depends on what is the tire pressure, maximum tire pressure that comes onto that pavement using the axle load survey. The actual axle load survey is done. From there, the maximum load that is coming and the tire pressure that is being applied is taken into account to conduct this particular test. So the roller is removed and the wheels are put in together, and then we are doing the rutting test. This is a performance test. But one step I have still not shown you the video. Now I am showing. The previous video was about the preparation of the slab or the entire pavement composition. After that, we will be trying to apply the load using this roller. Now, when the design has to be made, we need to understand whether the densification has taken place, whether the stability comes into it all. So for that, the slabs can be compacted using RCRA, and you can see here, these are the slabs which have been compacted, and you can take the core to do all the tests like your Marshall method test or any indirect tensile strength test. All these things can be done, and the core can be extracted from the slab using this core cutting machine. It is similar to your pavement field where the slab is subjected to this particular core extraction, and the densification data is already known either by using sand replacement method in that particular hole, and once that is all done, it is patched. Now, in the same way here, once the core is drawn from the slab, this slab you can see is a slab of DBM which is being constructed using this particular RCRA. Now, once the slab cores are taken out, and then you can do the test. You can see here. Can you see the specimen being lifted in the core? You can see the specimen comes out. So this is how we are trying to change the complete scenario of mixed design by just changing the compaction approach. Instead of going for this Marshall or your super pave mix designs dynamic, your gyratory compactor, all that we need to do is to have this particular equipment, and this equipment is not fixed. It has got 4 wheels. It can be transported any place. You can do the field test also by using the power of the generator, which is to be carried along with this particular equipment. So anywhere, any place you can set up your laboratory, and the compaction that comes from this particular roller compactor is a true representative of your field compaction. We have laid the test track using the mixed design conducted using the Marshall method, as well as the method of your using the roller compactor and as well as the gyratory compactor. Roller compactor rut analysis values are more correlating with the field condition cores, which are compacted using the normal compactor. So in the sense, the field compactors, big rollers, are all in compacting in case of your roller compactor in the laboratory. So the shift of the binder content is very much true without causing damage to your aggregate structure. This is a major breakthrough, first point. Second point, the same equipment can also give you the condition or the performance of the bituminous material with the pavement in terms of rutting when the rutting takes place. So it's a total quality control check that can be introduced in the mixed design, and design is based on performance tests, not on a recipe or empirical postulates. So the entire compaction effect can be created in the laboratory, and it will be a true indicator of field compaction. Now the mixed design will be finalized based on performance evaluation rather than recipe standard. So roller compactor cum rut analyzer is a true performer and a vital tool for selection of better mix which performs in the field. I'll just skip this. So I'll say this is, I thank you for your patience listening. I was given 1 hour, 15 minutes. I think I've exactly tried to match that, and another 15 minutes for your question and answers. In case if you have any question and answers, kindly you can ask the questions. I'll be very happy to answer back.
Thank you very much, sir. It's a very interactive session. Even participants are having a few queries. They are posted their questions in chat box, sir. So the first question is from Fakir Mohammed. Is asking what is the importance of air void content in bituminous pavements?
Yeah, very, very interesting and very important question to this topic, Fakir. Yeah, I would like to say, see, the breathing of your pavement. In my lecture, I was trying to say that if you look into the overall content of this pavement layer, top layer, it is aggregate, bitumen, and air voids. Now, during summer, this bitumen, because of the temperature of the pavement, over that, even the vehicles which is running causes friction. You know, the tire, due to its acceleration and deceleration, adds additional temperature to the pavement temperature. Ambient temperature plus pavement temperature, when it rises up, the bitumen has got its tendency, as I told you, it's a material which is susceptible to change in its property with change in temperature. It starts from its solid state to become semi-solid, and then it starts moving as a liquid. Now this air void content, if we are not fixing it properly, or we are not giving scope for this bitumen to adjust its liquid content in form of air voids or the gap, it starts coming onto the surface. It is called as bleeding. It is a failure. It's a functional failure, and as well as it leads to a lot of skidding and various other issues. So this air void content also defines when your pavement has completely been compacted. Now, when we compact the pavement initially, depending upon the temperature, the binder content of that particular project, we leave about 6 to 7% air voids. So now this has to be reduced over a period of time. When the vehicles are moving, additional compaction takes place. Over a period of time, this comes down to 3%. Beyond 3%, the pavement failure is bound to take place in form of shear. So we always try to play within a window of 4% of air voids. Now, if you look into the ministry's mixed design, each section 500 for each layer, for your DBM structural layer and as well as BC, they have specified the targeted air voids, about 4% or 3% targeted air voids. So when we take up that 3 or 4 is the minimum content of bitumen, which is required for 3 to 4%. Over a period of time, due to this fluctuation in temperature, this bitumen, when it tries to become semi-solid and becomes liquid, so if it is more than 4% of air voids, that bitumen is occupied in air void place, or the space left out, which in the 3-phase diagram, if you see aggregate bitumen, the bitumen takes the space of the air void. This is a very important parameter when a mixed design has to be made. We need to achieve, and a targeted value is always given by the agencies like the ministry under section 500. It gives for each layer. That can be taken as a reference. This is the importance of air void. So it completely balances the change or the fluctuation of the bitumen turning to solid to liquid and liquid to solid.
Sir, one more participant, Manish S. Darek, is asking how effective is usage of plastic waste in flexible payments? Technically, what modifications does it do in the bitumen mix?
Yeah, this particular is a very hot topic, Manish. But I would like to say is that itself is a big game changer, and there's a lot of both physical characteristics improvement and as well as chemical characteristic improvements. And not all plastics can be used into the pavement construction or can be used into bituminous mix. There needs to be a knowledge of what type of plastic gets into this, because each plastic has got its own softening point and melting point, and each plastic has got its own components. There are several noxious gas coming out of it, so rather be careful when you're handling this, in case if you're handling it. So with this note, I would like to say that the plastic basically modifies. See, when we all know that the aggregate and as well as the binder, when we look into bituminous binder, they are not compatible because they have the same chemical or what we say the ion pattern. They don't like each other. They always tend to move away. Like if you bring two North Pole magnet, how they repel each other, the same way aggregate and bitumen, when you hold it, the surface doesn't attract the bitumen to hold it. So what we do is we raise the temperature flux, or we raise the temperature and change their surface charges and make them bind together. Now in this process, if you add some kind of anti-stripping agent, like say hydrated lime. Now the hydrated lime changes the chemical morphology or the complete chemical texture of the aggregate and holds the bitumen in a very better manner. When the binder tries to enter in between these 2 points or these 2 bondage, then the repelling action takes place. If it is not there, the water, when it comes, once this material is heated, they are changing their chemical or they're changing their ion exchange and they bind. But after cooling, the water, the aggregate which has got silica content in it, starts absorbing the water. It has got an affinity to pull the water. Now when this water comes and it separates this bitumen, basically the debonding takes place. That is what the stripping takes place. This is what I was telling. Apart from weight, water damage, moisture susceptibility is what is causing this failure of bituminous mixes. If even the weight is not so large, the moisture damages the pavement. So to avoid this plastic, which is again a petroleum product, byproduct, and bitumen is a petroleum product, but the plastic has got a very good bonding capacity with the aggregate. So a layer of plastic, if it is coated on aggregate, the affinity of the aggregate to pull the water is completely lost. Second thing is, since bitumen is also a petroleum product, plastic is also a petroleum product. If the bitumen is added to this aggregate, which is coated with plastic, it holds together. Now this comes with a very low cost because the plastic is going to be a waste one. If we burn it, it is going to cause a lot of problem. If you put into ocean, it is going to cause landslide. If you try to put into the landfills, it is going to cause a lot of problem for us. So the best way is to reuse it in pavement layers in form of this bituminous mix. Again, I'll tell you, it comes with a rider. Not all plastics. People who have got knowledge about the plastics and handle this bituminous mixes, they will prepare this type of plastics which goes into the bituminous mix, where the temperature, where if the bituminous mix is about 165 to 170, even at that point, the plastic should not release any noxious gas. It should not melt. It should not get burnt out and all those things, and it should not cause harm to the equipment and as well as environment. Such plastics are added, and they in turn will hold the binder together. So the moisture effect will be nullified, or we can say it is reduced in plastic usage. And second thing is the load carrying capacity of the aggregate mix increases, because this bitumen and the plastic, they increase the tensile strength of the mix. So plastic has got higher tensile strength. That is why we will be spending several dollars to bring the polymer modified bitumen rather than virgin bitumen or the normal bitumen. Polymer modified bitumen increases the tensile strength. So we are getting that by adding waste plastic. That way it is going to really help us. So the plastic has got two advantages. One, it increases the tensile strength of the mix. Second, it retards the moisture damage. I hope I have answered your question.
Yes, sir. Sir, the next question is Dr. Kumar R. Rao. So asking, how is the reliability of roller compactor based mix design ascertained on actual field performance potential?
Yeah, very, very good question. See, we have done a lot of statistics. So that's what I was trying to say. We did with the three equipments, basically the Marshall, then we have our gyratory compactor, and then the roller compactor. So the roller compactor test, and as well as we have laid the test tracks. In the sense, the mixes that have been coming out with these three have also been put into the field. We are not just talking in the laboratory, and monitored it for 3 cycles of this particular road, where the performance of the roller compactor, first of all, when the mix design was done, the binder content was obviously high in case of our Marshall method mix design compared to the gyratory and roller compactor. That itself was quite a proof for us that yes, we are going to get a better results, because when the binder content increases, optimum binder content increases for the same aggregate structure. Only thing that we have changed is binder remains the same, aggregate remains the same. Only thing is the way we have compacted. So the compaction itself has broken the aggregate. That could be the conclusion. How can we do that? By taking the course and by bitumen extraction and finding out the percentage of the materials on each sieve size, which we have earlier taken, and reverse engineering, we have come to know that yes, definitely it has broken the aggregates, and the small fragments have been more damaged, and the surface area has increased, and this has caused to or tend to push towards more binder content. Now the roller compactor, since it is matching the field compaction, the values, the statistics, the standard deviation values that we have taken, the variations that we have observed over a period of time in the data, rutting analysis, or the rutting that has caused on to the chainage of Marshall, rutting caused on to the chainage of mix designed by the gyratory compactor, rutting measures that we have taken in field condition using this standard procedures we have taken, and roughness that we have measured. Roller compactor and the gyratory compactor have shown a far promising results than this. So that itself is more than sufficient for us to say the reliability. Now again, the acceptance level, it should come when the people have to accept this, we have put it across to IRC. Let us see what IRC says. When the IRC, if we ask for more reliability, if they want to do with the more and more national highways with this particular mixed design, and that in over a period of time, that the results itself will talk about the statistics and reliability of this particular equipment.
Sir, one more question from Dr. Skand Kumar. It's asking, is presence of surface water is considered in RCRA since surface water has major significance in the performance of pavement?
See, surface water, basically, no one designs the pavement where the water is going to stand and then the pavement has to stand for 24 hours, water has to stand for 24 hours and do it. Our aim to give the camber in the field is to see that the water doesn't stand on the surface, drain out to the surface or the nearby CDs or drains which are provided. So our damage which is caused onto the surface when the water stands for a longer duration. So that is the first thing. But in our roller compactor and rut analyzer, we are not talking about the moisture damage because of the surface. We can do by sprinkling the water onto the surface by the tubes. We have that provision also in our roller compactor, as well as we create artificial rain, and we have also got, I'll just show you the equipment where we have made that provision. So here we have also made the provision. You can see an upright surface which is standing. Basically, this has got tubes here where this can come onto the surface and continuously provide the water, as well as these tubes have also got heaters. Now these heaters, when the sun's UV rays, this sun UV ray can also be provided onto this particular surface to understand the aging condition. With the aging, conduct the test of rutting with the presence of suns as well as water. So moisture damage is basically because water is standing onto the pavement. That itself is a different scenario. No one in the world can design a compactor where they are going to take the moisture and do it. It is a different scenario. I'm telling you, it is about the chemical morphology which is going to come between the bonding of the binder and the aggregate. So aggregate, when it is to be held with the binder together, if the water enters as a third agent, it tries to strip. When does that can happen? When you give opportunity for the water to stand on the pavement. Our aim is not to stand, allow the pavement. Now to make it densify without allowing the water to enter into it, reduce the permeability without allowing the water to enter into the pavement surface, densification takes place. Densification is the part of the compactor. Now the compactor densification using Marshall, it is a dynamic process, it breaks. At that point of time, people did not have so much of sophistication, so they were using it. Then why did the gyratory compactor come in replacement of Marshall hammer? It is because they have seen the way we are designing in laboratory and shifting those results to the field. It is not going to give us the correct results. So that is why they invented this gyratory compactor. We thought the gyratory compactor, yes, it is a costly equipment with all those things. Now with our condition in Indian scenario, if we use the gyratory compactor, the skill labor required to understand the initial gyrations, what is the maximum gyrations and all those things, entering it, sophisticated air operating compressors, drying cells, all and passing through this, it takes a lot of effort and money. It comes not less than 20 to 25 lakhs. So with this particular scenario, how many contractors will come forward to use that? And only for one compaction, if they are buying such huge equipment, it is not going to solve any problem. So there should be a compaction way which should be similar to the field condition needing action. This roller compactor has come. It has nothing to do with the moisture. Moisture, we have a separate test, AICTE-T283. Material which is used with roller compactor means slabs compacted using roller compactor, then drawing the cores, and gyratory compactor cores or gyratory compactor cylindrical specimen, and Marshall specimen we have tested for T283 Astor test with conditioned and unconditioned test, indirect tensile strength. We have seen the gyratory compactor specimen and roller compactor specimen coming in neck to neck in their moisture susceptibility damager, where it is going to be much better than your Marshall. In terms, if you want to talk in terms of statistics, the statistics is it is more than 2 times effective more than this particular Marshall method of reaching, whether it may be for DBM, whether it may be for your BC, bituminous concrete grade 1 and grade 2, or dense bituminous macadam for grade 1 and grade 2. So surface water we can add to simulate the rain condition and run the rutting test, accelerated rutting test to this. Now here there are 2 components one should understand in this research. One is to fix the optimum dosage of the bitumen content, we are using this roller compactor. Now once that is done, we are going to construct the complete pavement component, and the optimum binder content which I have designed using this roller compactor, using that a slab is cast, and then we are measuring the rutting potential of that particular pavement with various temperature and various tire pressure. If 10 kg per centimeter square due to overloading it comes, what is the effect? If it is 60 degree, whether that binder can sustain more number of repetitions. If it is a new material which has come in between, for example, we are doing CTB, CTBS now in 2018, AICTE-37, cement treated base, and we had cement treated sub bases. So if we introduce such kind of a pavement layer with the existing other materials like BC and DBM, and we do the rutting test, how the rutting test results will come with CTB and non-CTB, that conventional pavement happens. So for that, we don't have to wait, construct a test track, spending lakhs of rupees, do the test and come. This total model box, which has also got scope for introduction of embedded strain gauges. We have strain gauges which can be embedded through this, and that strain gauges will give me the strain values that are coming at this interface of these layers. That will also help me to use in IIT Pave directly. So the E value, modulus value, if I am able to get, I can play with the thickness of the pavement, whether it is required or not, whether the 8 templates that are there in IRC37, are they going to really work? Even with the confidence interval of 70% also, if I am able to prove with this particular test, or if I am getting the results with 70% confidence interval, then shifting those results to field for a first trial tag will be with more confidence. Otherwise, no research or no person will come forward with the new material. If neither of the national highways or state highways, they'll say, no, you don't have past record, you don't have any experience in the field, we cannot risk to give this. Now, if you test here and give, so there are 2 advantages of this equipment. One, mixed design, another one is to give the scope. So the answer to Skandakumar is that we don't design any pavement to water to stand on it. In case if it stands, it is to sustain. The sustainability comes with the material property, not with the compactor. Compactor will make only densification, and we are talking about densification method while doing the mixed design is done by Marshall is wrong. It disintegrates the aggregate. What we are trying to say is use this compactor, which is similar to your field compaction. So with confidence, you can shift the value. I think I have answered the question.
Sir, we are getting a lot of questions, sir, but we are running time. But I'll take one last question, sir. The question from Nagashri, she's asking, what is the credit of reclaimed asphalt in compressive strength behavior compared to conventional one?
See, this is a very vast topic. Like when we talk about reclaimed asphalt, it all depends on what exactly you're talking about reclaim. What is the percentage you're talking about reclaimed asphalt? Now, what kind of rejuvenators you are using? What kind of agents that we are going for to use this? So If you are talking the compressive strength in the terms of what, there's no, the normal design what we do for our virgin aggregates or the mixed design that we do. In place of that, if we are using 30% or 40% of reclaimed asphalt aggregates with which have got which have passed all the section 500 tests, such the shape, it has retained the shape, crushing and all the strength. Definitely it is going to work similar to your virgin one. Absolutely, there is no this thing until and unless if you are treated and you have seen that the aggregate which is coating onto the or the binder which is coating onto the aggregate is completely removed and thoroughly removed, and the new, or if it is not removed, the rejuvenation of the existing binder is having the same elasticity with the virgin binder, definitely there should be absolutely no problem to use the reclaimed asphalt. Again, and days are not far when people have to definitely use this. Now we have seen most of the quarries being shut down because of the environmental constraints and Supreme Court giving. So this is a new arena where we are talking about the reclaimed asphalt payment. The existing payment has already proven, already you are passed. The same thing you are going to place into the road, and road has been performing. Now we are removing that and reusing to construct in the same place or some other place. Now while removing, it is the art in which you can remove these aggregate without damaging them. So we have also done a research on that, where the existing milling techniques which are there, which are going to damage the shape factor and the size of the aggregate and various other issues related to the strength of the aggregate, we have also got a different procedure to remove this. We call that as shallow depth milling. Now that shallow depth milling, we try to retain this, and we have gone up to 70 to 80% of this virgin aggregate. We are replacement of virgin aggregate. Only 20% is replaced to hold that particular aggregate matrix within the range of what the agencies have said. And it is not just one road we are talking. We have already laid this in Karnataka State Highway Improvement Program under K-shape. And we have got a success answer. Only thing is the acceptability levels of our engineer is what is to be looked into. There are answers. The thing is impossible. We can use that, and they will have the same compressibility strength like what you get in case of virgin. I think I've answered the
Yes, sir. Yes, sir.
question.
Yes, sir. Sir, thank you very much, sir. It's a very interactive session. Our participants are getting benefits from our shared thoughts. Sir, in your busy schedule, even though you have accepted our invitation, and we know that the pain you have taken, you have shared all your thoughts. Even today, you came and you shared your thoughts in very well way. And behalf of Jyoti Institute of Technology and IST, AICTE, we are thankful to you, sir. In coming days, we hope we will going to organize much more event like this. Please accept our invitation and give your suggestions and share your thoughts, sir. Thank you very much, sir. Thank you very much, sir.
Thank you. At the outset, I would like to thank the organizers for giving me this opportunity to share my few thoughts, which I think if it is really converted and it has motivated your participants, I'm overwhelmed. And yeah, as you said, we are always there. We will be there anytime. You can call us for such kind of events. We are always open to discuss and present what is going on. Several research are going on in the institution, which I think I could not share in this platform because of its non-disclosure agreements that we have signed, and many research which is going to come in reality, which is already a reality, and which we are executing with National Highway Authority of India. You will see in few days to come, it is going to come in a bigger way in a major projects. I hope this particular lecture which I have delivered has impressed you, or I given you the complete content. In case if you have anything, I am always there. You can reach me at Dr. Kiran Kumar at ka.gov.in. Sorry for that, I have not written here. I can share it with the participants. You can write a mail to me in case if you want any other queries or specific answers which you have not been taken up in this particular discussion and you have a doubt about this solar compact or anything. And you can anytime visit our institute and it is available. The equipment is very much available in the institute and it will be, our research scholars are also working on it. You can have a full-time look at it and understand in a much better way. You are always welcome to it. And I thank Keshav for inviting me to this particular session. I don't know whether I fit into this since he said anything related to research, you can speak and motivate the people since it is a research oriented thing. So I thought this would be a better one. And I felt whether you need to decide whether this particular roller compactor is going to be a boon in mixed design or it is going to be a curse. I say it is a boon for people who want a quality road and it is a curse for people who do not want this kind of a quality control to be taken over by the laboratory, so that they have very stringent way of mixed design. So people will be very much, obligated with the procedures and other things. So in both the way, it has got its pro and cons, but I find it is more pro to be, because it gives you a quality product at overall. Thank you, Keshav. Thank you, the management, which has given me this opportunity to share. And at last, I thank all the participants for being patient and listening for 1.5 hours continuously. Thank you.
Thank you very much, sir. Thank you, sir. Dear participants, regarding today's session quizzes and all, we will post by the evening within 5 p.m. So we hope you people are enjoyed this session. We will share materials very soon, and also we will share the contact details of Professor Dr. Kiran Kumar sir. If you're having any queries, you can post your emails and you can meet the sir in institute. Thank you very much, dear participants. On behalf of AICTE, ISTE, and JIT Institute, today program we are going to wind up now. Thank you very much for your support in all 3 sessions. Thank you.
1 second, Keshav.
Yes,
I
sir.
am
Yes,
just
yes, sir. Yes,
posting
sir.
my email address
Okay,
to
sir.
the
Okay,
chat
sir.
box
Okay, sir. Okay,
so
sir.
that people can write there.
Yes, sir.
Just
Yes, sir. Yes, sir.
yeah, I have just posted my email address. You can write to this email. Thank you.
Thank you, sir. Thank you, sir. Please, in chat box, the email ID is available. Please make a note. You can having any queries, because several questions posted in the chat box as well as sent in WhatsApp messages. Because of time, schedule, duration, we can't take all those questions. Please, if you are having any queries, you can post to sir email. Thank you, dear participants, and thank you, Kiran sir. Thank you very much, sir.
Thank you, Keshav. Thank you. Bye.